And so it's not equal to, so what is it?
Smaller to 0.
No. So if we were to, let's say we rewrite it as, x squared, x, and then the plus c, so that's less than 0. And then if we were to times everything by minus 1, so that would be positive 2x squared, positive 5x, negative 3, still 0. And with inequalities, if you times or divide by negative, the sign will change.
Okay.
And so you'd go about doing that one. So any idea what you do there?
Solve it. So 2 times minus 3 is minus 6.
Okay.
So and then we have to add to make it to find plus 5. So plus 6 minus 1. So 2x plus 6, 2x minus 1.
Okay.
And simplified to get x plus 3 and 2x minus 1.
Yeah.
And then we found that so x equals minus 3 or plus a half.
Okay. Yeah.
And then from there we draw a quick sketch of a graph. Plot minus 3 and a half on the and then draw a U shape.
Yeah.
Going through. So that's the thing I don't understand. Why is it upside down instead of?
What's the y intercept?
Minus.
Go back to the original. So if x was 0, what y would you get?
0.
So 0 squared, 5 times 0, and then the first thing.
Okay. So 0 squared is 0 times 2 is 0. And then 0 minus 5 times 0 is still 0. And then 0, 0 plus 3 is 3.
Yeah, and so that goes through plus 3. And basically it's a minus 2x squared. So if the x squared is minus, it will be upside down. It'll be an N shape.
Oh, okay.
So you kind of rearrange it just to solve it, but this is the actual one that they wanted up here.
And then after that, I'm not sure.
Where is the graph less than 0?
In the middle. I mean.
So you know how like y equals this thing, 3 minus 5x minus 2x squared. So where this thing is less than 0 is the same as where y is less than 0. So where on the graph is the y coordinate less than 0?
Below the x-axis.
Yes. And how could you describe that in terms of x?
When x is minus 3 or a half.
So that's when it's equal to 0. When does it become less than 0?
Okay, so when it's less than minus 3 or a half.
So it's when it's less than minus 3, or you see how it's like to the right of a half?
Yeah.
And so that would be greater than. So the y coordinate of the graph is less than 0 when x is less than minus 3, and when y is greater than a half. and you could sub in some values, like you could sub in -4 for x, and you should get an answer that's less than 0. You could sub in like 1. If we sub in 1, 3 minus 5 is -2, minus another 2 is -4, and that's less than 0.
Okay.
So if you subbed in -3, you get exactly 0. If you subbed in a half, you get exactly 0. If you sub in numbers less than -3, you get less than 0, or more than a half, you also get less than 0. And so those are the solutions.
Okay.
Any questions about any of that?
No.
So this is real tricky stuff. Alright, let's try this one.
2 and 7, so I'd say -7 plus 2. So x equals 7 or -2. So then with the graph, plot 7 and -2. The u, okay, so it's more than 0, so is it a U shape instead of an N?
That's not relevant. So you said the 2 points where it crosses the x-axis.
Yes.
What point does it cross the y-axis?
0.
So to find the y-intercepts, to find the x, the roots, you let y be 0. To find the y-intercept, you let x be 0.
Okay.
Because x is 0 on the y-axis.
Oh, I'm still not sure to this.
Sub-0 for x, what do you get?
-5 and then -14 again, -19.
That would be if you subbed 1 for 0 for x, sub-0 for x, 5 times 0.
0, so -14, sorry.
Yeah, and so the number that doesn't have an x in it, that's always the y-intercept. So that's -14, and so what shape will it make?
Okay, so it's always c in the equation ax squared plus bx plus c.
Yep.
Okay. So it's a u that's going to go through the -2, -14, and plus 7.
Yes, and you have a positive x squared, and so that's why it's a happy face. It's minus x squared, sad face.
Okay, but I thought it was to do with the -14.
That's also another reason why it goes through there.
Okay.
But it has nothing to do with less than or greater than. This is just a graph of y equals x squared minus 5x.
Okay. At school, we weren't worrying too much about the minimum point, so -14.
So that's just to help you to get the right shape. An easier way is to just look at that. If that's positive, happy face. If that's if it's minus x squared, sad face.
Okay, but if I were to do it during the exam, I wouldn't lose marks, would I? If it was not in the specification.
No. For quadratic inequalities, no. But I'm just thinking, if there was a different question that wasn't inequalities, where they just asked you to sketch the graph, then they would like to see this point.
Okay.
This is an important point, and so you would get these two and that. And so just in general, I'm just kind of teaching you for when you do all that stuff as well.
Okay. And so x, so -2 is larger than x, which is smaller than 0, smaller than 7, sorry.
So we want where this expression is greater than 0. So we did y equals x squared minus 5x minus 14. X squared minus 5x minus 14 is equal to y. That's the graph we did. And so we want where y is greater than 0. So where on our graph is y greater than 0?
So sorry, do we substitute that whole equation with y?
You don't have to, but I mean, we just drew y equals x squared minus 5x minus 14.
Okay.
And so basically, if you want where that expression is greater than 0, that's the same as when y is greater than 0, the output of that expression.
Okay, so where y is greater than 0 is above the x-axis.
Yep. And so where is that in terms of x?
Inside the shape. I mean so the lines that are above the x-axis on the. I think I'm not sure.
So y is less than 0 when x is between minus 2 and 7. Where is y greater than 0 in terms of x?
Yeah, above the x-axis, but I don't know what to say in terms of x. I don't know what you mean when you say that.
In terms of x, it would be when x is less than minus 2. So when x is more than minus 2, the y-coordinate is lower than 0. When x is less than minus 2, the y-coordinate is more than 0.
Okay.
And on the other side?
I understand what format you want now, but the fact why is minus 2 bigger than x here? Because it's above the x-axis, yes.
Yeah, so that's one of the solutions for all of the x coordinates. Like let's say when x is minus 3, you'll get a y coordinate that is bigger than 0.
Okay, so is 7's larger than x, isn't it?
So just in general, just in your own words, how would you describe in terms of x when the other side, when y is greater than 0?
Oh, I'm not sure.
So y is greater than 0 when x is greater than 7. On this side, y is greater than 0 when x is less than minus 2. Y is just a short name for this. So basically, x squared minus 5x minus 14 is greater than 0 when x is less than minus 2 and when x is greater than 7. So to the left of minus 2 and to the right of minus 7 is when it's above the line, when it's more than 0.
Okay.
Yeah, I'll get there.
Yeah, okay, I'm beginning to understand a bit better, I think.
So let's say okay, see this graph down here?
Yeah.
So this we have to solve let's see, we have to solve this here. So what is the solution using this graph?
X is larger than minus 2. Yeah, x is larger.
Yeah.
And then x is x is also larger than 6.
So let's say here.
Yeah.
Is that less than 0? If you had an x coordinate of 7, you would have a y coordinate of more than 0? If you had an x coordinate of, let's say, 5, it'd be something like there.
Okay.
What would the y coordinate be? More than 0 or less than 0?
Less than 0?
Yeah. And so these are the ones we want. These ones in here. This one out here, y becomes greater than 0, so we don't want that. We want less than 0. So the first part was right. When y is greater than -2, and when x is greater than -2, and when x is
smaller than 6.
yes. And another way of saying that is when x is between -2 and 6. They both mean the same thing, and both are correct.
Are the signs always in the same direction?
If you put the two together, yes. They both point to the left. So you can have the negative on the left and the positive on the right.
Okay.
Okay. So same thing, same everything, except I'm going to switch it to greater than 0. So this time, x squared minus 4x minus 12 is greater than 0. Where?
When it's above the x-axis?
Yep. And so in terms of x?
When when -2 is larger than x. I think. I'm not sure.
Yeah, so basically when x is less than -2.
Okay. And when x is greater than 6.
Got it. That's it. So that's all they're asking you to do. So they've just graphed this thing, x squared minus 4x minus 12. So they just graphed all the possibilities. Like when you sub in -2, you get 0. When you sub in 6, you get 0. In between those answers, you get negative numbers. Like if you sub in, I don't know, -1, you'll get a negative answer. And so that's why it's below the line. If you sub in something like -3, you'll get a positive number. If you sub in something like 7, you'll get a positive number. And so when it's less than is in between -2 and 6. When it's greater than is when x is less than -2 and bigger than 6. That's all.
Okay.
That's all there is to it. And the graph is just to help you, really. Okay, so this is a negative one.
So
let's do this.
But surely here it says that 0 is smaller than 6x minus 2x squared.
Say that again, sorry?
It says that 0 here is less great than 6x minus 2x squared.
So I'm just gonna, I don't know what you're looking at, but
Yeah, that one, the one you've left.
so 6x minus 2x squared is greater than 0.
Yes.
This is the graph of y equals 6x minus 2x squared.
How can the number be negative if it's larger than 0?
What number?
X. How can x be negative if it's larger than 0?
Let's take a look. So
I mean, basically, how do you identify whether it's below or above the line now? Because that's what I don't understand. Or
so let's say if I subbed in 1 for x, so -2, 1 squared, oops, I get 4, and so like 1 across, 4 up, that's probably somewhere like there. And so if you sub in 1 for x, you get a positive number. Let's say I subbed in 5. If I sub in when x is 5, I get a negative number, and that's probably somewhere here. And so all they did was all those answers, they just drew them all, including like when x is a half, when x is a quarter, so all possibilities. So they just They just put in all the possible answers that you can get, and you will just say, so it'll give you exactly 0 when you sub in 0 and when you sub in 3, and then you have to say when it'll give you numbers that are more than 0. And we already found one of them, and that was when x was 1.
Okay. Okay. So x can't be 0 and 3 if it gives you exactly 0.
True. We want when it's greater than 0.
Okay. Just sorry, you probably already said this, but how do you know it's going to be greater than 0 if it's below the x-axis for this example?
If it's below the x-axis, then it's less than 0. Below the x-axis, that means 6x minus 2x squared is less than 0. So I subbed in 5 and I got minus 20.
Yeah.
So when x is 5, the answer is minus 20, and that answer we call y. And so that one goes below the line. Same thing here.
Okay.
If I subbed in minus 1, I'd get a negative answer as well. We want when do you get a positive answer.
Okay. So x is x is larger than x is larger than 0, I think.
Yep.
But less than 3.
Alright, but yeah. Great, perfect. X is less than 3. That's it. So fully correct, and someone else might write it like that, which just means when x is between 0 and 3. Here, this is where it's bigger than 0. It's when x is between 0 and 3. That bit up there.
Okay.
That's all there is to it. Okay, and then extension. Where is 6x minus 2x squared less than 0? When does that happen?
So when it's above the x-axis?
That's when it's greater than 0. We want when it's less than 0.
Okay, so below. So 0 is greater than x, or x is less than 0.
Yeah, so 0 is greater than x is the same as x is less than 0. And x is greater than 3. That's it. Great. Any questions there?
No, no, I don't think so. I just need to do more examples.
We can do another if you like. Just want to see if I have one that's already sketched. I suppose I could just sketch one myself. I can just sketch one. Okay, so let's say this one. So this is x plus 1, x minus, or x squared, okay. So where is x squared minus 4x minus 5 is less than 0, so solve that one.
Okay. 1 and 5, so minus 5 plus 1. So x is minus 5 plus 1, so x...
We already have the graph. This is the graph.
Oh yes, sorry. X is... So x is larger than -1.
Yep.
And I'd say it's also larger than 5.
So it's less than 0 when you go to the right of -1?
Okay, so it's
So that's
x is less than 5.
Say it again, sir?
X is less than 5.
Yes.
So we're basing it off the y-axis.
Yes, because we sketched y equals x squared minus 4x minus 5. So we're just, you can just replace that thing with y. Just, that's all it is. Y equals that. We sketch y equals that. And so when is that less than 0? When the y coordinate is less than 0. When is this expression greater than 0? When the y coordinate is greater than 0. And so solve x squared minus 4x minus 5 is greater than 0.
Is greater than 0. So x will be less or greater than 0 when it's above the x-axis. So so when it's above the x-axis, when x is less than -1.
X is less than -1.
And when x is greater than 5.
That's it. Well done. Any questions there?
No, I don't think so.
No, I think you've got it. And I think this is pretty tricky for GCSE. I'm not sure if this is even necessary for GCSE, but I'll take your teacher's word for it. There's nothing more to it than that. If you want, we can do something different, or if you really want, we can do more of these.
Is this just it for GCSE, you think?
I don't think you even really need this for GCSE, but I'll take
I mean, he did admit it was a 4 or 5 marker that we would do these on, but yeah, I understand. It's quite difficult, to be honest. We can do something else if you'd like.
Anything in particular that you want?
No, the next topic this week was cancelling out on algebraic fractions, and I was okay with that, so I think you should pick.
Alright, we've never done Venn diagrams. I'll just skip to the exam questions. Give these a go. I'll just jump in and see if you know how these work. So this one up the top. Sorry, let's do this one here underneath it. Any idea how you do part A?
Of question 5, yes.
Yeah, question 5, part A. Any idea what the answer is?
No.
That symbol, N, for it means intersection. It means like both and, fish and chips. What numbers are in both?
2, 4, and 6.
That's all there is to it. So curly brackets, 2, 4, 6. How about very last one? Oh wait, very last one's huge. How about C part 1?
Okay. Q or S T, or just Q or S. So
that one is Q R S. Yep. How about this one up here? Part A, question 4.
Is it just two normal Venn diagrams?
Sorry, without drawing a Venn diagram.
I'm not sure. It says A, B, so...
Yeah. So, oh, sorry, here's...
Oh, there's a code up here. Okay. C, just C.
Yeah, it's just C. Hold on. Okay, and then this one up here. Exam question.
What does it mean when they have an apostrophe in the corner? For example, for F, with question 4.
F, that means not A. So the numbers that are not an A.
Okay. The top one you said?
Mm-hmm.
Which one? A number is chosen at random?
Yeah.
Okay. 6 and 9?
Mm-hmm. And do you know how you would write the probability of getting a 6 or a 9 from the universal set?
No.
How many possibilities are there?
2.
And how many possibilities in total from the universal set?
9.
And so it's 2 out of 9.
Okay, very simple.
Yep, I agree. Okay. Let me see this one. Okay, let's do this. Okay. Let's try question 1. U means union. And so that just means everything in A as well as everything in B. That's like either or. Except you don't repeat the same thing twice. You don't need to. So what is A union B for this one?
1, 2, 3, 4, 5, 6.
Yes. Oh wait, no. Try again.
Or just 1, 2, 3, 4, 5.
Yes. 1, 2, 3, 4, 5. That's it. Okay, try this one up here.
Uh, 15 and that's it. 15.
You're thinking of N. This is union.
Oh, 3, 9, 15, 21, 27. So 3, 5, 9, 15, 21, 25, 27.
Yep. And they wanted probability.
7 over 8.
Odd numbers less than 30. 1, 2, 3, 4. So it's 7 possibilities out of how many odd numbers are there that are less than 30?
15?
Yep. So it's 7 out of 15.
Okay.
That's it. That was a union. 1, 7 out of 15. Same idea, except this time you've got 3 things going on. So try this up the top.
Two, 8. 2, 6, 8, 10, 14, 20.
You are thinking of union. This is intersection, both A and B.
Yes, isn't it? 2, 6, 8, 10, 20, 14?
You're thinking of union. That's A union B. That's in either A or B. We want only the numbers that are in both A and B.
Oh, okay. 8. Just 8.
So just 8. Probability.
Is it 8 over 12?
It is. That's 12, and it's not 8. How many
It's 1 over 12.
Yeah, and that's quite a common thing. Just watch out for that. It's easier when they use letters. Okay. Let's use this. We'll make our own little Venn diagram. Okay, let's do question A. Put them in the Venn diagram.
Um, 1, 2, 3 in A and 5, 6 in B.
Hang on. Let's do question B instead. Sorry. Okay, how do we do B?
Same as A. Oh, so A, B in A. Then C, D in the middle. And E on B.
Is that everything?
F in B as well. Oh, no, F outside the 2 circles.
Well done. Okay. So let's try exam question down the bottom.
1 and 5 in A. 6 and 9 in the middle. 8 and 2 in B.
Say it again, sorry.
8 and 2 in B.
Doesn't look like 8 and 2 are in B.
You're right, sorry. Just 8 in A. Yeah, 8 in A.
Okay.
And then 3 and 7, I think, are outside.
And what you might find helpful is I always start from the middle first. So
Okay.
6 and 6, 9 and 9, and I cross them out as I go. So then I put a 2 in B, then a 1, 5 and 8 in A, and then cross them out from up here as well.
Okay, and the 4 as well, I would say, is outside.
Oh yeah, that's why it's a good idea to 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Let me see this one. Odd numbers less than 30. They really like this stuff. I think you're okay for these ones. So this is 3 rings. Let me see this one. Let me see. I'll go with this. What is question A?
Letters that are in both A and B.
Mm-hmm.
So D and H.
Well done. What is question D?
Letters that are in both A, B, C. So H is the only one.
Well done. Okay, we'll do this exam question down the bottom.
So 2, 10 and 14 in A.
What I recommend is start from very center, work your way out.
Okay. And there's nothing in the center. So
There's nothing in there. Yeah, you're right.
no, there's not. There's 8 in both A and B, and 20 in B and C.
So there's 8 in both A and B.
Yes.
Okay.
And 20 in both B and C.
20 in both B and C. Okay.
2, 10, 14 in A afterwards. 6 in B. And 8, 18, 22 in C.
8, 18, 22. And did A and C have anything in common? 2, 10, 14, nope. Okay, is that it?
Yes.
Universal set.
So the probability?
Nope. Universal set. Even
Oh.
numbers between 1 and...
12 outside.
Okay.
14, 16 outside as well. 16. 18, 20, 20, 24 outside as well.
4. So we have, let's see, 22, 24. So we did 2. I don't see 4 anywhere. So,
Yeah, you're probably right. Put it outside as well.
so 4. Do we have 6?
Yes. In B.
6, 8, 10, 12, 14, 16, 18, 20. Do we have 22? Yes. And we now have 24. Yes. Well done. Great. Not easy. And that's what we get. Hold on. Is that the right one? 8 in all 3? Do I have the right one here? 8. Ah, 8 is in all 3.
Is it?
Yeah.
Oh, surprising. I didn't see it at all.
How did we miss that one? Oh yeah, we had 2 8s. Oh, so 8 is in all 3. And was there anything in both A and B? 18, 20, 22. No. Other than that, yes. Good. Okay. We just missed that simple thing. Okay, how do we deal with this?
So 3 Venn diagrams overlapping.
Mm-hmm.
So I'll probably do it as a tally, maybe. Is that good enough?
Start from the very center, work your way up.
Yes, but what do I write as a letter or a number or a line? A tally in the Venn diagrams?
I'd use a number.
Okay, so 2 in the very center. So 4 speak French and Spanish, so I put that in the FLS.
Yeah.
7 speak German and Spanish, so I put that as well. 7 in German and Spanish.
I'm not sure. It doesn't say, but not French. So it might just be in total.
Okay.
So
8 do not speak languages at all, so I put that outside.
So we can definitely do that. Yeah, we can always do the very middle and very outside first. Then we try to do these 3 middles.
10 people who speak German speak at least one other language. Okay, so 31 speak French. We have to minus the 4 and the 2 for now, which gives us 25. So probably put 25 in French. So I don't think there's anything else related to French here.
Might be. Let's see. I just want to stick with this one. 7 speak German and Spanish. So this is German and Spanish. So we know 2 of those people speak French as well.
Okay, so 5.
Yeah, so actually that's 5. Okay.
10 people who speak German speak at least one other language. So if in the last one, FG, there's a 3.
Well done.
Okay, so then from then we can do 22 being the number of French speaking people, I think. Yeah, and then 2. And yeah, I think that's it.
Hold on. What do these all add up to?
44.
How many people were there in total?
50, but how do we know that the others...
So let's see. 31 speak French. Okay, 2 speak French, German, and Spanish. 4 speak French, but not German. 7 speak German and Spanish. 8 don't speak English at all. 10 people who speak German. Doesn't say, am I right?
No, I don't say.
I just want to see about German. 2 people speak. So 2 people speak all 3. 4 speak definitely not German. 7 are German and Spanish. 8 do not speak any at all. And 10 people who speak German speak at least one other language. That's that one. There really is no way to know. So let's just assume that that's the remaining 6. And so what would be the probability?
That they both only speak Spanish. 6 over 50, which can be simplified.
You don't need to. 6 over 50 is fine. You're right. 6 over 490. Did they do some wacky stuff here? Let's see. So 0 speak German, but not French or Spanish. So we're correct about that one. Oh, hang on. Two of the 50 people chosen are chosen at random, not 1. This is the probability of 1.
Oh, okay, so 3 over 50? Yeah.
Hang on. So no. So that'll be 3 over 25, but then that'll be 9 over 25 times 25. Is that? 6 over 490. See this? So number speaking Spanish only over 50 times number speaking Spanish only. This is a crazy difficult one. Crazy difficult. You know how it's 6 over 50?
Yes.
This is conditional probability. So what they should have said was one person is picked and not replaced, and then a second person is picked.
Okay.
So if one of them has been picked, then how many are left?
49 and 5 over 49. Okay, yes, I understand.
And so that's where it comes from. And then, quite unhelpfully, they gave it to us in a simplified form, 6 over 490.
Yeah.
But not fully simplified. There you go. Oh yeah, so you can actually see it here. That's a 1, and that's a 10. Yeah, 6 over 490.
Oh.
So 490. Wow, terrible question. Let me just go back a second. Just want to make a note of this. Terrible question. Oh, I know it came up. Sorry, terrible question. So I don't use that one again. I just want to see these. Oh, great. So we got through all the times that Venn diagrams have come up on GCSE so far. Because it's relatively new to GCSE. This is the same as we did, is it? Did we do this one already? Yeah, we did this one already. I think these might all be the same. Odd numbers less than 30. Oh, we want B, is it? What's the probability of numbers in the set A union B? No, we did that. And then this one was when they all had 8. They wanted so put probability questions with originals. Yeah. So it's just about finding the probabilities. That's okay. Yes, so quadratic inequalities. It's just about when the y is less than or greater than 0 in terms of x.
Okay.
And then for Venn diagrams, I recommend you do the very center first and then work your way out to do the less centers. So if there's 3, do like this one first, then these ones second, and then these ones third.
Okay.
And you can do the outside at any time as well. Yeah, how was that for you, Hugo?
I mean, the beginning was quite hard, and I'll probably have to go over that again, but the Venn diagram's alright.
Okay. Is there any topic in particular you want to go through next time?
No, I'm not too sure.
So I'll just put down maybe conditional, no, probably 1 minus probability or conditional probability, but I'll just have to make sure. Any questions for me in general?
No, thank you very much.
Alright, well done Hugo, you did great, and I look forward to chatting again next week.
Yeah, thank you very much. Bye.
Have a good week, goodbye.